Are artificial intelligence systems truly intelligent, like human intelligence? Or is it something different? Is it more like artificial achievement? Well, my guest today is Gilles Gignac, who's an associate professor of psychology at the University of Australia, Perth, and he's actually started researching these very questions. He's also very interested in, can we actually measure artificial intelligence systems correctly? Or are benchmarks that are commonly used saturated and they don't really work because they have too many easy questions and they're just too long? So this makes it very difficult to actually compare AI to human intelligence. Gilles has actually proposed alternatives in his papers, and we get into some of his ideas today. He's also an expert on metacognition, narcissism, and human financial literacy, as well as personality and intelligence. Enjoy my conversation with Gilles Gignac. Let's talk about how we actually define intelligence in humans and machines. So I know you worked towards a construct definition in your papers. So some of the things you've included are novelty and being able to achieve a novel goal at maximal capacity. So let's just talk about how that works in humans and AIs or machines as well.
Yes, well, I think it's a very important issue if we're going to discuss the nature of LLMs and what they're doing, if we want to think about it as intelligence or something else. So in that paper that you're referring to, Gignac and Szodorai from 2024, we provided a definition for intelligence, but we also provided a definition for something that we call artificial achievement. So really I think the main contribution of that paper was to go, this is what intelligence is, and this is what achievement is. Both are valuable, they are different. And so, yes, for intelligence in humans, we define it as the maximal capacity to achieve a novel goal successfully using perceptual cognitive processes. And as you mentioned, novelty is a key characteristic in that definition. And, I often say to people, in a basic sense, intelligence is what you do when you don't know what to do because you weren't told how to solve this problem. It's not me who invented that term, that goes way back. And novelty is that characteristic of I don't know what to do here because I was never instructed how to solve this problem before. And that's novelty. Maximum capacity, that's important because intelligence is not a personality trait, it's a cognitive trait. And we consider personality more your typical behavior, the sort of thing that you're going to do day in, day out on a regular basis. But intelligence is something that you could do in your maximal effort. And people have high correlations across time when it comes to exhibiting their maximal capacity. But you just have to make sure that when you're testing someone's intelligence, they are sufficiently motivated, for example. For LLMs, it's not a problem because you would assume that that's one of those constructs. Motivation in LLMs, hard to think about it, but it's interesting to think about it. For humans, it's perceptual cognitive processes. And for LLMs, the definition is exactly the same thing. So achieving successfully a novel goal with maximal capacity using computational processes. That's the only difference between the two definitions. One is perceptual cognitive, the other one is computational processes. And we felt that was important to do because if we are not talking about the same constructs across the two entities, then we have to take that into consideration and just go, whatever LLMs are doing, it's not intelligence. And it's not necessarily a bad thing. It's just different. And if we want to make comparisons, we have to have a similar construct. It's just operating through different processes. That's the theory. So contrast that with artificial achievement and also human achievement, which is more what you learn through training and practice and instruction and feedback. That's achievement. That's what people do in school. That's what people do in university. We give people very specific instruction and they practice that and they learn it. And we call that achievement. And that's really a great thing too. But it's different than intelligence. And the reason why it's so important to distinguish the two is that we know that intelligence in humans predicts a lot of things in life much more substantially and more broadly than academic achievement does. Academic achievement predicts things in a more narrow sense, whereas intelligence is this construct that predicts things in such a wide way that we are fascinated by it.
You did very well there bridging both disciplines like AI and psychology. Like that's probably the most impressive version of that bridging that I've seen. But can we get to a substrate neutral definition of intelligence that doesn't depend on these perceptual cognitive processes or algorithms? Or do we have to accept that intelligence is going to be different in different entities? So an example here would be a paper you referred to in your paper in 2024, which is the Legg and Hutter paper from 2007, where they define it as intelligence as something like an agent's ability to achieve goals in an environment. And they try to get to this universal definition of intelligence that is substrate neutral. But you take a slightly different approach to that, because you obviously talk about perceptual cognitive processes in humans and algorithms when it comes to machines. But can we
Yes.
get rid of the substrate here and take a functional approach?
Well, I would say that we also advanced operational definitions of intelligence. So we provided those abstract definitions. But then when you think about it in more concrete terms, and you almost have to do that in psychology because the definitions in an abstract sense, you're stuck with, well, how do we actually measure this and what do we do with it? And the reason why I'm saying this is that from a psychometrist perspective, in a pure sense, they don't necessarily care the substrates that mediate the performance, so long as it meets the criteria for standardized measurement. So if novelty is compromised, which means the person was given the IQ test 2 weeks earlier, and here you can practice it, that is a compromise. And the substrate is the same. So the human has a neurophysiological system to mediate cognitive behavior. The test is compromised because now it's no longer novel. In the context of a practical operational definition, we said it was to solve a task or a standardized test with veridical scoring, which is a fancy word saying widely agreed upon correct answers. That's really all that veridical scoring means. We widely agree that there's a correct answer to this question. In personality, there is no right or wrong answer to the questions. If you're an agreeable person, that's just how you describe that in your context of your personality. It's not right, it's not wrong. In intelligence, it's very different. And in achievement testing, it's very different. So from a psychometrician perspective, to get back to your question, to me, it doesn't matter so much whether the substrates are different. I actually don't, it doesn't matter to me. And to push it even further, even in humans, when they solve intelligence tasks, they don't all use the same strategies to solve exactly the same task. So for some spatial tasks like mental rotation, some people actually try to solve that task in a verbal sense. And other people use a gestalt way. They literally are manipulating the object. They tend to do, in my experience, they tend to do the best. That actually is the best way to do the task. But some people will try to use a verbal strategy to solve a mental rotation task. It's not purely verbal, but they use a verbal type of crutch when they do it. And when it comes to getting the score, they could score really high on the task, and so could the person using a more gestalt approach. And to a psychometrician perspective, they both have the same level of intelligence. As long as the task was novel to each and they were maximally motivated, that's fine. It's more of a theoretical issue as to whether the substrates are exactly the same. And that's still interesting and important to look at, and especially in the context of some people arguing that unless they're arguing that there's something special and unique about the neural architecture of the human brain that a artificial system will never be able to reproduce or replicate and achieve that level of performance. Now, there are synthetic approaches to try to reproduce something like a neurophysiological net in the brain, and that's an active area of research. And there are some people who are saying LLMs are a dead end. They're not going to get us to where we want to go. So we have to go to an area where we need to try to reproduce something closer to the neurophysiology of the brain. But the neurophysiology of the brain is, on the one hand, is super amazing. But on the other hand, the average human has a maximal capacity on average of working memory equal to 4 objects. That's not impressive. 4 chunks of information in your mind to manipulate at the same time. When you compare to LLMs and the capacity that they can have in terms of pieces of information, tokens, whatever you want to call it, it's much higher than what humans are. So I guess the last thing I'll say for a long-winded answer to your question is that the substrates are interesting to look at from a theoretical perspective, but it's not necessarily the case that an artificial system will always be weaker than a biological system.
So definitely human working memory is limited, and that's without a doubt. Like obviously machines have a much higher capacity and bandwidth for that. But in terms of data efficiency and learning efficiently, like humans are much better at that than machines are. Like these LLMs are trained on a huge corpus of data. Humans compress data much better, and obviously a baby can learn language from much less training or seemingly much less training, and they can input data from different modalities. It doesn't all have to be language. So are you impressed by that? The fact that like humans are much more data efficient and the brain
Yes.
seems to get there much easier.
Yes. Look, I'm super impressed by by what humans can do, especially when it comes to learning. What's interesting about learning is that it is such a fundamental basis of experience for humans in terms of our advantages in life. If you can learn quickly and efficiently, that is such an advantage, even if you go across species and also if you go across to artificial systems. And humans almost seem, we've evolved to be such good learners, such zero shot learners, to use your description. We don't need a lot of examples to learn something really quite quickly. LLMs are not like that. They need a huge amount of training. And that is an ongoing challenge for LLMs. What's interesting about learning, though, is that as much as, pretty much everybody would say the capacity to learn quickly and efficiently is such an advantage, we don't measure it in IQ tests. Like if you look at the Wechsler Adult Scale Intelligence tests and the other popular comprehensive intelligence tests, we don't measure learning. We measure, I think, possibly the outcome of learning, like a vocabulary test, for example, is a measure of crystallized intelligence. And people would argue is that that's, one theory is that it's, the investment theory is you apply your fluid abilities, broadly defined, like reasoning, working memory, attention, processing speed. You apply that and you accumulate crystallized capacities. It's not one to one. You also need exposure, yes, and you need motivation and those sorts of things, yes. But we don't measure learning. We could. So you could give somebody a task like, here are 30 words I know you've never come across before, with like 99.9% chance you haven't come across these words before. Here's an hour, and I'm going to give you examples of the word in usage. I'll give you the definition. And then after an hour, we're going to measure how many of those new words have you consolidated in your vocabulary. That would be a pretty decent measure of learning in a very circumscribed way. The reason why we don't do that is because we only have about 60 minutes to measure someone's IQ, maximum 90. So human IQ tests are, in my opinion, super impressive on the one hand, and B, they're compromises. We make compromises when we test a person's intelligence. With LLMs, they're given tens of thousands of questions. Some of these benchmarks have just enormous amounts of questions applied to them, which is a very big difference. But getting back to your question, large language models, it's very well known and very well discussed that they don't learn on the fly. Once they are pre-trained and fine-tuned, they're pretty much static. You can have a huge context window, but even then, like I've come across so many errors when I use LLMs. They are not learning. They are incapable of doing it so far, but that might not be always the case. But it is a huge difference between humans and LLMs, this capacity to learn on the fly.
Because if you clear one chat in ChatGPT or Claude or whatever you're using, it starts afresh. So it kind of wastes all this discussion and data, and it just starts a new conversation again, which is completely different to the way humans actually work. Let's just talk about generality, because obviously you touch on generality in your papers, and you actually found there is a positive manifold in LLMs. So will you explain how that works, why generality is so important for human intelligence, and why it might be so important for LLMs as well? And then we'll talk about why this might change, as obviously different frontier labs actually take different avenues or routes towards post-training. But in terms of like pre-training and actually size of the parameters, the amount of parameters in the model, you did find a positive manifold.
So that's right. Across a couple of studies, and we looked at it in two different ways. And I suppose the reason why we looked at this is that the construct of general intelligence in human research is very important. There's a lot of research on it. It's also very controversial, by the way. In psychology, the general intelligence is not something that people totally absorb and accept. And I'm predicting the same thing's going to happen in artificial intelligence. Actually, this is like I'm getting a sniff of it that there's a percentage of people who work in computer science that actually don't want to see a general factor of artificial intelligence. This is my sense. In humans, your capacity to solve a spatial problem is correlated with your capacity to solve a verbal problem, which is correlated with your capacity to remember digits and is correlated with your capacity to process information quickly. And, that's a very simple way of describing the positive manifold. There are these meaningful 0.45 to 0.65 correlations across tasks when you test humans on a large number of tasks. And this phenomenon is impressive because the factor is so big. It usually accounts for 40 to 50% of the variance in individual differences. So it's very big. And the question for decades and decades is, why does this thing exist? Because it correlates and predicts things in life like longevity. It predicts academic performance. It predicts job performance. It's just such a robust predictor. And so the question is, naturally, might we see the same sort of phenomenon in LLMs? I should say that we hear the acronym AGI a lot, in the news and on podcasts. But when people in computer science use the term AGI, my sense is they're talking about a level of intelligence. It's like when you can do what humans can do at that level of capacity, some sort of basic definition like that. But general intelligence is not something that we see only in adults. We see it in children. We even see it in other species, like dogs. It's been replicated that we see a general factor of intelligence in dogs. So it's not
That's
a
really cool.
level
I've
of
seen that research, but
intelligence.
it's fascinating that it does occur in animals. It's really cool.
It does occur in animals. This is probably about 5 or 6 species so far that have exhibited. Even fish exhibit a general factor.
And
And the
birds, I
question
think.
is, you know, birds, yeah. The question is, why does that occur? So I would, look, the ship has sailed. I don't think computer science is going to listen to me in the paper and say, oh, we should think of general intelligence as a construct that represents the positive manifold. They're just going to use it as a level of intelligence equal to humans. In the papers that we worked on looking at the general factor in LLMs, it was just an empirical question. If they tend to do better on one task, do you see a performance that is correlated with another task? And we found that the general factor in larger language models was way bigger than what you find in humans. Now, I should say the tasks were all verbal in nature, so there was some homogeneity there, more than you would do typically. But even beyond that, it was much bigger. Now, so there is a general factor in LLMs, and I don't know if it's a general factor of achievement. I would probably say that when we published the paper back then, which was based on data from, not in the last 18 months, I would say it's primarily a general factor of achievement because it's mostly based on pre-training. My hunch is that the strength of the general factor in large language models will decrease in size because large language model frontier labs are spending more and more time on post-training, and they're post-training in a very specific way. They want to improve a model to do this type of thing better or this type of thing better. And that starts to deconstruct the general factor because now they're trying to go for specific abilities, basically. They're trying to fine tune it to do very specific things. It could be computer programming, it could be something else. Whereas 2 years ago or more, most of it was all just training on the mass corpus of the internet data. And they're all trained kind of in the same way. And so we got this huge general factor. So I predict the general factor in LLMs will decrease in the medium term. But is that the answer to your question?
Yeah, but like in the early stages of post training, we are just trying to develop an assistant model. We are just trying to get the model to respond coherently and safely. Do you think you still see it there? It might actually be reinforced with post training up to the point where maybe you get specialization. Like for instance, Claude, obviously, Anthropic has gone big into coding, whereas maybe OpenAI is more like a broad assistance model. So do you think at the early stages of post training, you might actually reinforce this positive manifold, and then maybe it diverges later?
It's possible. I mean, it's possible that if they're post-training in a similar way, that you will see the reflection of the G factor, even in that case. Where it will start to decrease is when they start to post-train in unique idiosyncratic ways. That is where you'll see a divergence in the strength of the general factor across time. So that means, I mean, and you even see that where if you look at the benchmarks closely, when they release a new model, you'll see improvements on something like coding. And because they're thinking about that, they're focusing on that because they've fallen behind and they're like, we need to focus on coding. And then you look at performance on other benchmarks, they actually go down. There are cases where
Wow.
they release a new model and performance actually goes down on another benchmark. And I guess they're like, we're willing to take that hit because we want to show people that, our model's a good coder. And that's very interesting from a human intelligence perspective because when you teach somebody something new, they don't lose information in another area. We don't have information to suggest that that happens. And in LLMs, in a very, when it happens very badly, it's called catastrophic forgetting. And that's where you post train a model and you change the weights, and the weights are actually used for more than one prediction, and then for that other prediction that you're not looking at anymore, you're just like, we're trying to improve coding. And then it's like common sense reasoning is going down. We're improving coding, we're reducing common sense reasoning because the weights are used for multiple processes at the same time. It's like gigantic regression equation where the weights are being used. And humans, this is a really important difference between LLMs and humans, is that humans is the opposite. The more information you have, the better you can consolidate new information. And we call it the Matthew effect. So it's kind of like the rich get richer. The more knowledge you have, the more you can accumulate. It's not like we have this finite resource of memory and then you start dropping off things. And there are, cognitive schema is one of the theories to explain why this happens. Is actually quite good research explaining why it happens. And that's such a fundamental difference with LLM. So they are very different systems. And again, going back early, is it necessarily worse? Not necessarily worse, but in this context, I would say it's definitely worse.
It's very interesting. You actually mentioned the Matthew effect there and the continual learning problem. So there's a really well-known podcaster in the US. His name is Dwarkesh Patel. Have you heard of him? So he
I
talks
have,
about
yeah.
this, this continual learning problem. He actually says that like it's easier to train a human assistant to do his assistance for the podcast because an LLM just can't learn continuously. So that's obviously a major issue, and maybe it's something the current architecture actually won't solve.
I know there are people working on this very problem of learning, and maybe imagine if there was a Matthew effect for artificial systems, it would just be explosive because they actually do have, in the context of saying that they have knowledge. I'm using that word in a very broad way. The Matthew effect should be ginormous for them, but it's really the opposite. And yes, and people, yeah, Dwarkesh Patel's like, until they actually can do learning on the job. He says, I'm not going to hire them, but he also says something to the effect of, they're not really going to have a huge impact on the economy until they do that. And then other people, like the CEO of Anthropic, disagrees, and he says, actually, they could still have a massive impact on the economy. And, it's an open question. I think they can still have quite a big effect on the economy, but whether they can replace jobs, it's not really just not being able to learn that is inhibiting that. I think LLMs also lack things like theory of mind and metacognition. And I don't know if we should talk about that now or later.
We'll actually come to that later. So, we mentioned in our discussions over email about pattern recognition, and this is actually like you pointed this out. This is very interesting because a lot of AI people would say, "Well, LLMs are doing pattern recognition, but so are humans. So we're both doing pattern recognition." But is there a difference between just recognizing regularities in data and what humans are doing, which is really solving novel problems almost from scratch? So the LLMs are obviously pulling the training data together, using that to recognize or to deal with novel, relatively novel problems, but humans are doing it perhaps much more data efficiently.
Yes, this is a little bit of a bugbear of mine of hearing people talk about pattern recognition and then saying, "Well, but humans do that too," and on the face of it, it actually kind of is true. So LLMs are trained on ginormous amounts of data, and then they engage in, they're subjected to post training, and in order to facilitate responses that are accurate, they act, the developers have the right answers, so they can actually check to see if the LLM's improving. And so when an LLM is given some sort of problem later, people would say, "Oh, but it's just going back into its training, and it's, predicting what the right answer is based on its training." And human intelligence researchers would say, "Well, humans don't really do that. That's not how we administer tests." But the computer science people would say, But if you give a Raven's progressive matrices to somebody who has never seen anything in their life, you take them out of a closet after 15 years and they've never seen anything. They're not blind, they just have never seen anything. And then you give them a Raven's progressive matrices. How do you think they're going to perform on that task? And that's not a bad counterpoint. It's an extreme one, but sometimes extreme counterpoints reveal a truth. And in this case, what people have to appreciate is that the degree to which test scores from an intelligence test represent intelligence is on a continuum. So it's not as if we say this IQ test score is 100% a perfect IQ test score, and this IQ test score is a 100% invalid IQ test score. You have to appreciate that it's on a continuum. And the degree to which there's more and more exposure to the human on the IQ test that you're testing them on, as they have more exposure to it, the more it degrades the validity of the test scores. So yes, people have seen shapes and various squares and sorts of things in their life before they've seen a Raven's progressive matrices. But when the test is at its most valid, it's when they've never seen a Raven's test before. That's the critical issue. And it will be to some degree compromised by their previously learned pattern recognition through experience and environment. Yes, it will be to some degree compromised, but it will not be fully compromised. Whereas in large language models, the open question mark is how much exposure? And if the exposure is very significant, then the degree to which the test scores represent intelligence is much more serious.
So you actually see a lot of computer science people and AI people they actually talk about two things a lot. So they talk about the actual ability measured through benchmarks, and they also talk about potential mechanisms. So a major theme I've seen maybe over the last year as LLMs did start to maybe plateau a little bit with scaling is they talked about how the brain works and can we make LLMs more like the brain or what are we missing? But something that psychology cares about is actually how intelligence is structured. So how the different abilities actually, how they cohere together. So for instance, if we talk about the G factors, so the general factor in humans, people have different theories about this. Some people say maybe it's a network of different sub-abilities working together. And some people say it's like, there's one thing at the heart of G, but you actually rarely hear AI people talk about how the abilities in LLMs cohere together. So maybe they're missing something there. They're not talking about the independence or the collaboration between different subsystems within the LLM. Like for instance, you mentioned in one paper this mixture of experts thing. But again, in the mixture of experts, like you have different experts within the dense neural net actually carrying out different subtasks. So they're kind of employed to carry out different subtasks depending on their expertise.
Yes, and you mentioned something halfway through that resonates with me about what is a theory of intelligence. And human intelligence researchers have been trying to develop theories of intelligence, and I would say that we are much more successful at developing psychometrics and statistical research than we are at theory. And in part, I think that is something about individual difference researchers who tend to do intelligence research tend to be more empirical and they tend less to be theoretically oriented. I can think of some really major intelligence researchers, one in particular who kind of poo-poos theory, it's not really interested in theory. But I do think theory is important, and people have been publishing papers on a theory of general intelligence. And one key difference is that when we think about intelligence in humans, it's pretty tough not to think of evolution. So why
Yeah.
did intelligence arise? Why did any individual difference, but especially intelligence, why did it arise? And it's really tough not to think about it other than in the context of evolution, at least in part. Whereas with large language models and artificial systems, how do we think about, if intelligence and evolution are so kind of closely related in humans, it is not closely related in artificial systems. It's hard to think of evolution in the context of artificial systems. So when you're trying to think of a theory of artificial systems and you don't have evolution to help you out, you're having to start from scratch and to think about it. I would say we're really in early days of trying to think of a theory of artificial intelligence. And to compound the problem is that in humans, the other part is when we think of intelligence and theory, it's really steeped in individual differences. So in addition to evolution It's also part of individual differences. How do you think about individual differences in the context of artificial systems? Why do individual differences exist in artificial systems? Whereas in humans, it's going to be I think it's going to be a different answer than why they exist in artificial systems. So I don't know if, coming up with a theory of artificial intelligence, I think would be great. And I think there should be more work on it. To some degree, because of emergent capabilities, it's a little bit of a black box at times. It's like, why is it doing that? We have no idea why it's doing what it's doing, even though it's doing it right. Going down the route of mixture of experts, I think, is going to further degrade the possibility of having artificial general intelligence. I think it's definitely a viable stream. And my sense with developers right now is that they're kind of going in that route. They're kind of going, why don't we just train them massively in very narrow areas, just massively, across hundreds of narrow areas. And they're kind of hoping that there's going to be generalization that occurs through that beyond the 200, 300 narrow areas that they train on. Like, then we'll see generalization. But that's not how humans work. We see generalization very early on in children. But part of the reason, I think Arthur Jensen, who was a big proponent of the G factor, didn't think the G factor was a psychological process. Certainly not how he described it in his book in 1998, The G Factor. He thought really mostly what it was is the intelligence is mediated by the brain, and different parts of the brain mediate different parts of intellectual performance. So if you see that, let's say, the parietal area has quite dense neurons and a lot of cortical surface area, you're probably going to see that the temporal lobe also has a lot of neurons and a lot of cortical surface area. And those two areas of the brain differentially impact performance on tasks that are different, verbal versus spatial, for example. And because there's a correlation between cortical surface area and density of neurons and et cetera, more complexity than that, you see a positive manifold in the brain, you see a positive manifold in performance. That's a non-psychological explanation for why the G factor arises.
Yeah, that's kind of getting at like systematic integrity. So just the integrity of the system is better, and this idea of like just general fitness is better overall. So maybe why more intelligent people actually live longer. But just on like the G factor. So I know you've published in this. I think you had a paper in 2008 talking about what might actually be the heart of G or how G works. So do you think it's like hierarchical with like one factor at the top and then maybe the other factors coming down from that? Or do you think it's more like a breadth factor? And like, what does that say about LLMs as well? Because obviously, I think in your 2024 paper, you found that like parameter size, like as the model gets bigger, this might actually account for the positive manifold. So how do we think about G in humans? There's no consensus on it. And then like a network model might actually work best for if we think of the context of LLMs, because obviously there might be these like slightly independent systems that actually maybe aggregate together over time. So how do we think about the G factor in humans, how it's structured, and how might that actually apply to LLMs?
Well, I'd probably say it's going to apply in a very different way. The G factor paper that you referred to for LLMs, we did use a bifactor model. To me, this is, if you get into the nitty gritty of these debates about the G factor and higher order models versus bifactor models, I've published several papers on it. I don't find it super interesting. There are certain circumstances under which you'll get exactly the same fit.
Do you
The
think it
problem I
matters?
have is I
Do you think
don't
it
think it
matters?
matters a lot,
Okay, interesting.
whether it's higher order or it's bifactor. I feel like it's so tough to distinguish between the two scientifically that it's kind of we can't even really talk about it. It's kind of like
Okay.
it's the problem of equifinality. You've got two models, they both fit well, and you decide on which one's simpler. Now, that's the debate about the G factor breadth versus higher order. Now, the issue of a network model versus a G factor, that's a more substantive question about, what is the nature of the positive manifold? Does it produce a latent variable that we can interpret versus there is no latent variable? There is no latent G. All it is observed scores. And what intelligence is what you get from the scores from an intelligence test. There are people who think that, people that I respect,
Like
who
Van der
think that.
Maas is a big one.
Yes, yes. And look, we don't have a method that can test definitively one way or the other. I think it could even be both. I think you could have a latent factor with a network model at the same time. I don't think they're mutually incompatible necessarily, especially when you think about the fact that I think it's fairly plausible that the correlations in the brain, the positive correlations in the brain, are facilitating positive correlations in performance. And so there is something there that's beyond just networking, but it's not cognitively interesting to think about it as, well, it's just correlations, in cortical surface area. It's correlations between neural density. It's interesting in other ways, but from a cognitive processing perspective, and that's where you get the debate where individual difference researchers, the more pure ones, they tend to be much more open to the G factor. The ones who are much more cognitively inclined, like cognitive psychology is not intelligence research. They tend to be the most dissatisfied with the G factor. The last thing I'll say, and I don't know if I'm really totally answering your question, but why does the G factor arise? And one simple description of how processing speed facilitates working memory is that working memory is finite. So, and it degrades quickly. So if you process information slowly, by the time you get to the fourth or fifth chunk and you're needing to work on it, your processing speed is not fast enough and you lost the first chunk. But if you process information really quickly and efficiently and it's coming in, then you can use your work, you can facilitate working memory. You're like, I'm actually managing 5 or 6 chunks right now because I process that information so quickly and efficiently. And that causes a positive correlation between your higher level processing speed and your higher capacity to manage working memory capacity. Now, to add to that, if you already have a lot of knowledge, let's say your crystallized knowledge is huge, and the first chunk you get is independent variable. And you're like, I know independent variables inside and out. And the second chunk you get is dependent variable. And you're like, you know, cinch. I've got this basically memorized so deep in my brain. I'm expending nothing on this. And then I'm talking about a main effect and an interaction. I see it in students that, they're stuck at independent variable and dependent variable like that. They're still stuck at that. So the point here, though, is that if you can process information quickly and you have a large database of knowledge already, your working memory is not taxed as much when you're trying to solve problems. And that helps facilitate positive correlations in performance. And a G factor can be as, simple, quote unquote, as simple as that.
Yeah, that's very well said. And that's obviously why fact learning is still relevant, because you obviously reduce this cognitive load, even though some people downplay the importance of fact learning. Now, let's just move on to benchmarks. So benchmarks is the consensus way to actually test LLM performance right now. But there's obviously a lot of things wrong with measurement here. And I don't think it's really like grounded in measurement science. So let's talk about what they do wrong. They might be too long. There's probably data contamination. There's probably poor item discrimination. There's a lot of things going on here. And I know you've thought about it a lot. So let's talk about it.
Yeah, so benchmarking in LLMs, which is basically the word of psychometric tests. So they were making psychometric tests as far as I'm concerned, but they used the word benchmark instead, even though they didn't. We would think of benchmark as having a normative sample, and we can compare against the benchmark, but it wasn't quite that. They were like, oh, this is a test, and we're testing it. Yeah, so I find early days, they were basically throwing the kitchen sink at the LLMs with like tens of thousands of questions. They weren't really looked upon very quickly, or I should say thoroughly. And in contrast with psychometrics in humans, we pore over every question and we wonder, like, is that a double negative? Is that going to cause validity to go down? So we really spend a lot of time on each question. You should when you create a test. So LLMs in the early days with the benchmarking, they were just like throwing out these, Hellswag and other ones that had these MMLU, had these massive databases of tens of thousands of questions. And David Illich and I looked at these. In fact, that's what we based our papers on, to try to look at whether there was a general factor or not. And that issue you keep mentioning, there's a correlation between the number of parameters and performance. There actually is quite a big positive correlation. It's not a perfect correlation, but quite a big correlation between scale. And people are asking that question right now about whether scaling will hit a plateau. And our paper was suggesting actually the plateau is pretty far away yet. Now, that was 18 months ago. Like, I don't know if that's totally true anymore, but 18 months ago, the scaling hypothesis was definitely still viable based on our research. The benchmarks we found out there were two, one big thing and one small thing. The big thing was training. They knew the questions and they knew the answers, and that was such a contraindication of intelligence testing. That's achievement testing. I mean, it's probably not even the best achievement testing, but yeah, so the exposure to tests compromises its capacity to represent intelligence when you define it as novelty. And that's why that definition is so important to go. It has to be novel. Like if people just disagree with that, then good luck to them. Their LLMs are not going to predict much beyond the test. The other part was, some of the questions didn't even have the right answer coded properly. So somebody said the answer is B or C, and actually the answer was A. And so there was like a negative item total correlation that you would get with that item. And so we dumped for some of the tests, we dumped many items because they had negative item total correlations. And, they just weren't looking at that. I don't even know the extent to which people look at that today when they create tests. What are the item total correlations? And the reason why is because you need a sample of 100 or more LLMs to get that variability in performance to run the correlations. And until you do that, you can't actually evaluate the quality of your test. And this is a bit of a challenge for me in the sense that I would like to do individual difference research with artificial systems. But when you use a platform like OpenRouter, I don't know if you ever heard of OpenRouter before, but they're a platform where they have access to, they say 300 to 350 LLMs, and you pay money and you can have access to them, and you can have access to them through the API. So you don't actually just have to go in the conversation box and actually interact with them. You can do high frequency testing through the API. And I finished a paper a
Yeah,
couple of months ago
I've heard of
looking
that
at,
process. Yeah. Yeah.
yeah.
So sorry, go ahead. Yeah.
Yeah, so I guess the main point I want to make is that there's tremendous value in research on individual differences in LLMs. But in order to do that research, we need access to the weaker LLMs. So what systems like OpenRouter do is they deprecate them, or the frontier models. They're like, you don't have access to that weak model anymore. And to us, like an individual difference researcher, we want the people who are lower in ability. If we don't have them, we have range restriction. And, running an analysis like the correlation between number of parameters and performance, if you want to evaluate whether there's plateauing going on and precisely estimate it, you need a large number of LLMs so that we can estimate, is it a quadratic effect and it's actually petering out? We need numbers. And my worry, I've sent emails to people and I don't get a response saying, we need a system like this. I send it to computer science people and they're probably like, we don't care about that. We just want to improve the models and that's it.
Is that because they actually haven't really got, I'm not trying to insult them, but they don't really implement measurement science as such. It's more like this constant trial and error. So just like you said, they're throwing this massive amount of questions at the LLM to try and test it. But again, it's not really grounded in any theoretical way in actually proper testing or measurement.
I would say in 2026, it would be unfair to say that all the people in the industry in the computer science side are not thinking of measurement seriously. Some are. Some are actually. And some people are trying to do computer adaptive testing and those sorts of things. I think some of them are starting to do it, but they're not necessarily at the frontier labs. I did see a job advert recently on my Twitter feed where one of the frontier labs was looking for a psychometrics person. But,
Wow.
it's their first, I think it's going to be their first psychometrics person that they're going to hire. And so they specifically mentioned psychometrics. And I think they're like, we need somebody like this. This would be
Wow.
valuable. So I think it's starting to change. And I think it will continue to change.
Talk about the paper you actually produced last year, where I think it was a 60-item psychometric test for LLM. So it's obviously much shorter. And obviously you got rid of a lot of the redundancy here. I think did you base it off 3 existing top benchmarks? So what are the advantages of that, and how might that actually allow us, this shorter test, to ask maybe better theoretical questions of LLMs and maybe get better comparisons between different LLMs and as well LLM to human comparisons?
Yeah, so the 60 item benchmark test, believe it or not, I think you can do it with fewer. 60 items was just what I
Wow.
chose, and I thought, well, people might find that palatable. Yeah, I think I just
That's
did
crazy that you
I
can do it
just,
with fewer than 60 items. That's insane, isn't
I
it?
think you can
It's
do it with fewer
it's
for
really cool.
some narrow abilities. Yes, I'll mention that study I have under review right now. The 60-item benchmark study was an extension of our other study where we looked at the G factor the first time in LLMs. And because we found so many items that were bad, they were either negatively item correlated or their item total correlation was so tiny you wouldn't realistically keep it under normal human testing circumstances. So I just thought, what if we actually thought, this is like, let's think of something novel. Let's think of picking one-third easy items, one-third moderate difficult, and one-third difficult. Like simple things like that. They obviously hadn't thought of that. And a sidebar there is some of these benchmarks like MLU and several of the older ones, they're saying, oh, they're saturated. We're like 95% correct. And that's because 90% of the questions are easy.
Yeah, I
There's
saw
like
that.
5% medium and 5% hard. So if you actually take out and pick one-third easy, good item total correlation items, and one-third moderate, one-third tough, their performance drops to like 60%. They're at like 90
Wow.
and they're like, oh, it's saturated. Oh, it drops to 60 once we have an actual variability in the types of questions included in it. So that alone to me is really quite a disturbing finding in the context of accurate uh, interpretations of what's going on with the LLMs. The other reason that David and I published that paper was because I want to do research with LLMs, like from an individual difference perspective and test their capacities. I'm not going to administer 10,000 items. I just refuse to do it. I'm not going to do it. And I don't think it's necessary to do it. So I thought, let's publish a paper where you can do it with 60 and you get as good, if not better results. I would say better, that we actually show
Really
that there's
cool.
better reliability, better convergentability. It's better. And that opens up the possibility for me to either create my own test that no one's ever seen before. I'm not going to create 10,000 items. I might create 30 to 60 items. And then I can test LLMs with that type of test and show that psychometrically it actually makes sense to do it. You can still get good reliability and you can still get good validity. And yeah, that brings me to the paper that I have under review right now, where I administered 32 questions to the LLMs, like a really basic reasoning task that I
Wow.
don't think they've ever been exposed to before. It's quite an old reasoning task, but I don't think the test has ever been published on the internet before. So the LLMs would definitely be familiar with the test, but they've never seen the questions before, and they haven't seen the answers. And one-third of them, and these are good quality models. These were not old models. One-third of them could not answer, and they could not answer at a level beyond chance. Now, to
Wow.
give you
Th- That's
an
sane.
example, this is it's bad, but this isn't the full story. So wait for the full story. Uh, to give you an example of an item, it's like A before B, A B, true or false. It's called grammatical reasoning. Some people call it semantic verification, but really it's kind of more of a grammatical reasoning task. Now, they can get tougher when you say A does not follow B, and then it's like BA or AB, and then you're like thinking does not follow. It's tougher. But humans are expected to perform at 90% plus on this if you give them enough time. It's actually a speeded test for humans. It's known as a speeded reasoning task. And you give them 90 seconds to complete as many of the 32 items as possible. They usually score about 65% is what you might get as a performance on it. It's tough. You can't do all 30. Most people can't do all 32 in 90 seconds. It's just too hard. But if you gave them 5 minutes, they would knock it out of the park because they're actually all quite easy. Now, I administered the same test to LLMs. 114 LLMs I managed to get that are sufficiently unique. They're not totally cousins from each other. And one-third of them could not perform above chance, but that means two-thirds could. Two-thirds could perform above chance. And 11 of the LLMs performed perfectly. And it was definitely a negative correlation between age and performance. So they were definitely getting better. And 11 of the LLMs performed perfectly. I created two versions of it, an A-B version, which is the well-known version. And then I created one with HW, like just totally, semi-random. They weren't random letters. I strategically chose those through quite a lot of thinking of what would be a good match. But I thought, if LLMs are trained on this task, when you give them HW, they'll do worse because they've been trained on A, B. So if they just literally kind of memorize the responses, they'll perform worse. And it comes out they do perform worse on the HW task. It's statistically significant reduction in performance on average, but it's not a huge difference. And get this, humans also perform worse on the HW version. And the degree of performance reduction is equal between humans and LLMs. They both find the HW version equally more difficult.
Does that undermine our point earlier that maybe pattern recognition is more sophisticated than humans, or the fact that maybe humans aren't just doing retrieval or broad search like LLMs are? So does that actually undermine that, possibly?
I actually think, look, I concluded in the paper that I think a percentage of the LLMs are actually starting to generate the capacity for narrow reasoning. I actually think some of
Wow.
them are starting to engage in reasoning ability, a narrow reasoning ability. Like on the one hand, it's like, wow, 11 of them got perfect, but that's not that impressive, because the items are not that tough. They should be knocking out of the park. So on the one hand, it's disturbing that 1/3 could not perform above chance.
That's
And it's
insane.
impressive that 11 of them could perform perfectly, but this is not a tough task, and they should be knocking out of the park. If they're doing other types of mathematical capacities, like some of these LLMs can do such good mathematics. Not they do make mistakes, but the fact that we reached ceiling with this task just recently with the most recent models. Yeah, so that's a long-winded answer to I was able to do other analyses from an individual difference perspective with these data, but I would say 25% of the models I tested in this study are gone. I can't get access to them ever again, not in an easy way, and that's very just detrimental to research on individual differences in artificial systems.
You hinted at some of the lingering fragilities in these models there. And I just want to bring in, so we kind of spoke previously in an email exchange about like metacognition and how that's an area of weakness, and perhaps like theory of mind, so mentalizing as well. These are potential weaknesses. Now, you also mentioned catastrophic forgetting. Now, Jeffrey Hinton has said that like humans can fabulate too, that we can say this is like a major issue for LLMs because humans do the same thing. But you actually mentioned the worst performance rule and why this might actually say a lot about LLM's limitations. So if you would mind explaining what that is and why it is significant. So it's not just the fact that they make mistakes, but it's the nature of those mistakes and perhaps the lack of awareness they're actually making them.
Yes. The worst performance rule is a fairly niche part of human intelligence research, but it's actually, I find it quite an interesting part, especially in this context. And
Before
basically,
you brought
what
my
it is
attention
that,
before you brought my attention to it, I actually hadn't. I have never
yeah,
heard of it, which is fascinating. So, kind of,
there you
it really
go.
got me thinking
Yes.
after you said it.
Yes. So the first performance rule is essentially the observation that there are individual differences within your own performance across tasks, or I should say across stimuli and tasks. So in a reaction time task, which is where we observe this mostly, or test for it, you're shown something on a screen and you have to make a decision, right or left. And it's a very basic thing. And it's measuring processing speed. And what we find is that when somebody is tested across multiple trials, they have their own variability in performance. Like somebody might be consistently, 120 milliseconds, and they're usually between 110 and 130, something like that. I'm just making up numbers. And they're consistent like that, and they're quite fast and they're quite consistent. But when you look at people who perform worse, a good chunk of the reason why they perform worse is because they have real humdinger clangers where they do like a 500 millisecond response. It's like they just had a brain fart and they're like, I don't even remember what the rules are, something. I don't know. So they really perform poorly relative to their own performance. And that, if you don't even look at the mean median decision time response, if you just look at people's worst performance and you correlate that with stuff, including intelligence, you find it correlates as well, if not better, than the median performance on a task. So you give it 50 trials, find their worst performance, use that as their only score, and then correlate that with things, and you will find predictions.
Wow.
And that's called the worst performance rule. And from my perspective, from an evolutionary standpoint, and really thinking of intelligence in humans, it's hard not to always think about that. Yeah, you kind of consistently go back there.
You're
The
dead.
reason why Yeah, you're dead. Like if you do a real clanger of a mistake many years ago and probably and still today, like if you misestimate the probability of getting hit by a car when you cross the road on your bike, and that happens daily. People are crossing roads quickly to try to get by and they just misestimate, they miscalculate something. Usually they can do the calculation accurately, but on that time, badly. And it is hugely detrimental to their life. And even things like misestimating investment risk, like if you're consistently, you're not very good at it, but you're not totally terrible at it. But then this one time you misestimate the risk in a particular investment and it wipes out your invest and your savings, and you're 58 years old or something like that. That is very hard to recover from. So that is something very important. And humans, they tend not to do massive clangers. The ones that did died. They're not around anymore. They haven't passed their genes on. With LLMs, you do see some huge mistakes that are just real huge head scratchers of why would they think to ever respond something like that? And a famous response. And I don't want to be laying the boots into LLMs. I use LLMs in my work. I think they're super impressive and they make huge, spectacular mistakes at times. And one of the famous ones was when Google Overviews was first started out. Somebody asked how to prevent the cheese on pizza from slipping from a pizza base, which is that common problem that a lot of people have when they add a lot of cheese on their pizza. And the LLMs suggested earnestly that you should add glue to the base of the pizza. And if you add glue, the cheese should stick and it'll have a reduction in chances of slipping off. And that's a really bad mistake to think that that's a good answer to a question. If a human thought that was true, they would get ill and it'd be very bad. And the reason why the LLM, in my opinion, the reason why the LLM failed has to do with theory of mind. And theory of mind is the notion that in humans, we grasp the idea that other entities, humans, have intentions and motivations, and they have a reason for why they did something. It's not just random things that are happening in the world. When organisms engage in behavior, they're doing it for a reason. And that's part of theory of mind. How someone might feel if you say something to them, theory of mind. Uh, the LLM found a Reddit response that actually somebody asked that question: how do you prevent cheese from slipping off of the base of a pizza? And they responded in a narrative format going, oh, what you could do is you could add glue to the base, and I recommend this glue, but this glue is even better. And the person was being totally ironic. They were just being funny. And that response got a lot of thumbs up because a lot of people thought it was funny. And the LLM could not distinguish between an ironic response and a genuine response. And it looks at the thumbs up and it's like, it's actually a good response. People think it's good. So I'm actually going to give it that response. And that's a catastrophic mistake. I mean, Google got a lot of bad press for actually having this happen. And LLMs continue to make these really bad mistakes. And in my opinion, it's part of the reason they do it is because they actually don't really understand what they're doing, because they're really just making predictions the vast majority of the time. Even though I do think they're doing some narrow reasoning in some cases, I do think they don't actually understand what they're doing. Because if they did, they would not make these gigantic, really bizarre mistakes. So as long as they continue to make the final thing I'll say about this is that when we look at the benchmark performance of LLMs and we see 85%, and we're like, that's very good, 85%. The question you should follow up with is, what were the LLMs thinking for the other 15%? Did they give just crazily bad responses? Because not all incorrect responses are equally bad. And if you're going to deploy an LLM in your workplace and 15% of the time it makes a mistake, that can be considered as, some people would say that's not high enough, but other people would say, I can work with that. But you can't work with that if among those 15%, they're deleting all your files or they're sending out a horrible email after somebody suggesting that they should add glue to their pizza or something like that. The type of mistakes people do matters.
I actually have a couple of observations based on what you said there. Before we had these large language models, AI people actually made a distinction between narrow intelligence, so like weak AI, and strong AI, which is more general. But it still seems that they're narrow because, again, they need human oversight. So there's definitely, we don't have this broad generality that people are aspiring to. And the other thing is, so Obviously, IQ tests don't necessarily consider theory of mind and metacognition or measure it, but perhaps it's actually very important to kind of at the meta level for human performance in daily life, even though it's not captured. It's probably assumed that you're going to have it, but it's not captured by traditional intelligence tests. You have separate tests for those elements of human cognition.
Yes. Yeah, very good point. And I do think that's an emerging area of intelligence research, one that I'm personally trying to push forward in recent work under review and in press. The idea of a theory of mind, do we measure that in IQ tests? No, we don't. We don't measure it. So, but there are some tests out there that are trying to measure it. They're not part of intelligence batteries. So there are some tests where they just show like the eyes, and you got to try to guesstimate what they're thinking and feeling just by looking at their eyes. It's like the seeing the mind in the eyes test is what it's called, something like that.
Is it
It's
correlated with
not.
IQ?
It is
How,
correlated with IQ. The problem, though, is that the test isn't great. And my sense with these tests, that one in particular, is there's a heavy verbal component to it. And I think that's a problem for the test. Also, it needs to be improved with better quality and better items, but it's a start, even though it's been around for years. It is a start to start measuring those sorts of things. But I think one point I would make here is that the correlation between conventional comprehensive IQ tests today and job performance, the correlation is somewhere between 0.45 and zero point 0.5. That's the correlation between intelligence and job performance. And if you square the correlation to get a percentage of variance accounted for, that implies that 20 to 25% of the variability in job performance is possibly due to intelligence. It's a correlation. We haven't manipulated people's IQ to see if there's a concomitant increase in job performance, but it's a robust correlation. So, on the one hand, that's really impressive. It's one of the biggest correlates we have for an important criterion. For comparison, conscientiousness, which almost everyone would think is a very important thing in the workplace, the correlation is about zero point 0.2. So 4%
oh,
of the variance. Yeah. 4%
okay.
of the variance in job performance is due to conscientiousness as it's currently measured today, which is a self-report questionnaire. Not perfect,
Yeah.
far from it.
It's probably higher
But
for academic achievement for conscientiousness, I would say. For
yeah,
academic achievement and
yes. And
conscientiousness, it might be a bit higher.
yeah, and so is the correlation between IQ and academic achievement. That's closer to like the point sixes and the point 0.65s. So you get a higher correlation in that context too. So, but the question is, what is all that other variance? Like 80% or 75% of the variance in job performance is possibly unrelated to intelligence? My response to that would be, our measures of intelligence today are compromises. We only measure it for like 60 minutes. We don't even measure a learning ability. As I mentioned earlier, I think if we had a good quality learning ability task in intelligence tests, the correlation would bump up. But I also think if we had some really good quality measures of theory of mind and metacognition, and so metacognition is where your estimation of the degree of the response that you provided is accurate. So, how confident are you in your response being accurate? That we can measure your accuracy in that. If you say this is definitely 100% correct and you're wrong, you don't have good metacognition. You screwed up there. Whereas if you consistently say, I don't know the answer to that question, and I really have to tell you, I don't know. And so you have some sense of what you know and what you don't know. That is part of metacognition. And how you manage that in life to improve it is also part of metacognition. That's a separate part. Very important. My hunch is that those two capacities, your capacity to infer what somebody else is thinking or feeling at the time that you're in a room with them, theory of mind, and your capacity to realize, I'm actually engaging in a cognitive bias right now, thinking about what that person is thinking. And I need to correct that right now because I know I fall into that trap. That's metacognition. I can't believe that that's unrelated to job performance. I think the better people are at both those two things, theory of mind and metacognition, which I actually think are measures of intelligence. We don't have them yet that are good, but people are working on it. And I think over the next 10 years, that's going to be I hope it's one of the bigger areas in intelligence research. We will then find a bigger correlation between intelligence and job performance. And that's important in its own right. Now, the other side is LLMs do not have these capacities. They're really not good at it all. It's very tough to even think how to help improve LLMs with that capacity. I don't think it's impossible, but it's not even really something that is a fully active area of research at the frontier labs. I don't know what they're doing exactly. I don't have insight, but based on the papers that are being published, I don't think it's happening, but it's really important. And to give you like an example of like a really concrete example of an error that an LLM made recently, well, actually, it was maybe a year ago, but I think it's such a good example. I gave it a snip of a large number of names of people who attended a meeting. And I wanted to know how many people attended the meeting. I wasn't going to count them all. I thought an LLM should be able to do this pretty quickly. And I snipped the PDF where the names were and I put it into the LLM. And one LLM, the first LLM said 110 names. And then the second LLM, I was like, oh, LLMs make mistakes. Let's see if I can get some reliability. I put it in the other LLM, 111 names. I'm like, somebody's wrong. It can't be both 110 and 111. So I had to count them myself. And I had to figure out where was the mistake. One of the LLMs made a mistake. And what's interesting is that the same name turned up twice in the list. And for one LLM, they interpreted my question to mean count the number of unique names. Then the other LLM just counted the number of names in the list in a much more, literal sense, or it's debatable which LLM is right. But if you gave this task to a human, and this would be possibly kind of like a common sense reasoning theory of mind test, a human should come back. If I gave that task to a human and I said, can you do this for me, please? I'm just so pressed under the time. Please count the number of unique names. I think a large percentage of them would say it's 111 names, but two of the names are the same. That is actually the best response in a workplace. But just saying 110, 111, the human has to think about, I know you didn't ask me to tell you whether there were more than one of the same names in the list, but I'm thinking you probably want to know that. And the truth is, I didn't want to know that because when you looked at the names, they were actually in alphabetical order. And let's say the name was Caroline McKinnon. Caroline McKinnon showed up once where the last name was for the M's and once for the C's. And I think the person just screwed up when they made the list and they added Caroline McKinnon twice. And it would be interesting to see if an LLM could figure that out. Why are there two names? Is it a mistake? Or some people actually have the same name. And, Caroline McKinnon is not that unique of a name. It could two people in the same area could have that name. Now, I know I've gone on a long time about such a simple thing, but in the workplace, there's so much of that going on where it's not according to the script. Like, we got to go off script a little bit right now. It's just a minor deviation and we'll figure it out. But if you make a huge mistake, or you're not even capable of thinking that the person would want to know two names are actually identical, neither LLM told me that, then, you have a problem with it. But I think that's an ability, the ability to go, I think the person who asked me to do this would want to know that there are two names that are identical. And that to me is actually an intelligence.
Very interesting. So what you're getting at there is like a lot of things that you actually do in your job are difficult to explain or put in words. They're almost like tacit knowledge, and they're like minor ambiguities that you obviously have to decide in the moment, and you might not even remember making that decision. And it kind of gets at something called world models. So there's been a lot of discussion over the last 6 months, maybe a year, about world models. And again, like a lot of researchers would say, like for instance, Yann LeCun is one, that we actually need world models and LLMs. So like there's different ways we could talk about world models, but should we talk about them in terms of metacognition and theory of mind, or is it more about interacting with the environment? Because again, obviously an LLM doesn't really directly interact with the environment, they're assuming it from language. So what do you think is the most important aspect of world models there? Because I think metacognition is definitely a factor.
Yes. Well, to my understanding is that when people speak about world models, they're mostly thinking about interactions with physical objects, the physical world. I don't hear them talking about it in the context of theory of mind and metacognition. I would say it's a world model with humans in it, but if you took humans off planet Earth, you could still have a world model, and you wouldn't have a model that needs to think about what other humans are thinking. So world models can exist purely in the context of its physical environment and understanding the dynamics of physical principles, which LLMs are argued not to possess. And people like Yann LeCun and others are working on world model approaches to develop AI systems. I think the bigger argument here is whether large language models, based on their current architecture, can take us to a type of intelligence that is sufficiently high and sufficiently general and commonsensical, like that example I just gave you. And it would be like, oh, the person probably wants to know that. Can LLMs get there? And so Yann LeCun is on record saying, no, it's not going to get us there. And if I had to bet, I would say that it won't get us there either. But I would also say that LLMs still have a fair way to go to improve. I think they can still be improved in a very significant way, even if they are not ultimately the destination of an AI system that will be able to do many of the things that people believe AI systems should be in the workplace. It should be said that not everyone believes that, by the way. Some people are like, this is not a good movement to have such a huge role of AI systems in people's lives and in the workplace. That's kind of a separate ethical issue or a social, political point of view. So my sense is that they won't get there,
But
but there's still a huge amount of progress.
I wonder, like, if you just reinforce these things in post-training, like metacognition and theory of mind, if you just reinforce the model to actually accomplish these, would that do it, or do you need like a separate complementary learning system, which perhaps humans actually have? So you need like a maybe one LLM looking at the other LLM, giving it feedback or something like that.
Yes. Well, I think if LLMs or any AI system can actually learn on the fly, that would be a huge leap. Whether that means they would actually still have a good quality enough of a theory mind, and could you actually reinforce them on enough tasks? I think the problem that you run into there is that there are just so many examples in life where it's like, oh man, Another example is AVs, automated vehicles. There's evidence that when they see a person walking on the sidewalk with a stop sign on their t-shirt, they will stop.
Yeah,
And
that's
it's kind of like,
it's
oh, so
funny.
now we need to reinforce learn an automated vehicle so that we got to show it like 10,000 t-shirts with 10,000 stop signs, and sometimes it's like crinkled and sometimes it's not, and sometimes the person's close to the stop sign, a real one, and sometimes it's not. It's my sense is that there are so many circumstances that are idiosyncratic and unique that the training won't get us there. But I
Yeah,
still think it can get us far.
it feels so patchy, doesn't it? That you have to like, there's these so many little holes in what they can do, and you constantly have to like cover it up. It's obviously just not the way humans work. Like, I mean, we teach a child manners, but we don't have to constantly like they can apply those manners or that politeness to different environments. We don't constantly have to reinforce it to that extent.
Yes.
So let's just talk about perhaps human amplification. Do you think LLMs, it looks like the way it's going now, they're not going to replace human cognition, they might augment it. So how do you feel about that? And do you think it could maybe raise general performance across populations?
There's two ways to answer that question. One is based on the research, and the other one is based on personal experience. And I would say that LLMs help me in my work and in my life. I use them very regularly. I think my productivity's increased 25 to more percent, and also the type of tasks I tackle are more complex than I otherwise would have tackled. Even the paper on human intelligence and artificial intelligence, I didn't know very much about artificial intelligence LLMs at the time. I mean, it helped me a great deal to be able to use LLMs to learn about it and verify information. Like on the one hand, they're very useful, but at the same time, I don't trust them, So like I double check everything. I don't assume anything is correct, but it nonetheless helps. When it comes to computer programming and also programming with statistics, I mean, to me, it's very obvious that they can help people in that case. And there is research showing that people can improve their performance with LLMs with humans in the loop, that they actually can facilitate performance in some cases. There still needs to be a lot more research done on that, though, because you can also get, I don't know, you probably use LLMs yourself, and you can get into a bit of a rabbit hole where you're like, I just need to solve this thing. I want to make this figure look a certain way. And then you're like, doesn't work, doesn't work, it doesn't work. And you should just be like, I should have stopped 20 minutes ago. It's not going to work. And I should have just stuck with the good enough figure and moved on with my life.
Depending on how you prompt it, like you can't really get eh, an opinion from the LLM because depending on the tone of the prompt, it'll kind of answer the way you want sometimes, or it'll slightly manipulate the data to represent kind of what you're looking for a little bit. So they're a little bit craven towards humans, perhaps.
Yeah, so that in the word there is sycophancy. So
Yeah.
they engage in a particular type of behavioral tendency. And apparently that's primarily achieved through the post-training that they do. I don't think they are natively sycophants. I do think that that's being achieved in and ChatGPT went through a bad period where I think it was like 4.1 or something like that was really quite heavy on the sycophancy. It's been reduced. Yes, you do have to be careful that it's really just trying to please you. Getting back to the question of benchmarks, there are leaderboards where they say this is what people are choosing as the best response from a particular LLM when it's head to head, and people pick that's the best solution for that problem. And there's very serious question marks about the validity of this. On the surface, it sounds good, but what people tend to pick often can be as simple as the response with the most number of emoticons. It's not because the response is accurate. It didn't produce a solution to that looping programming problem you have. It's just you like emoticons or you like a lot of, sycophancy. And it's like, I want to be told that I'm a great person. And you click on that one. And so the leaderboard is compromising. And then the frontier labs are actually training their models to be on the leaderboard. And that really is not a good pathway, in my opinion.
We got to finish in one moment, but you are so good with your time, and I actually really, really enjoyed the conversation. But could I just ask, could you talk just briefly about the Dunning-Kruger effect? Because it's something that comes up a lot on my Instagram. And again, I think it might be overemphasized a bit. And I read a little bit of your work on this, and perhaps it's a bit more nuanced than people actually assume.
Yeah, the Dunning-Kruger effect. I thought I would publish one paper on this and then get on with my life, but apparently it wasn't so simple. Basically, the Dunning-Kruger effect, you need to distinguish between two things. This is what people are confusing, including on research papers. So there is a such thing as the better than average effect. That is the notion that on average, humans tend to report their abilities higher than they actually are when they compare themselves against the normal population. So if you ask people, how good of a driver do you think you are? And here's a scale where it's a percentile scale. And the person's like 65%. You might get like 5 to 10% of people who say they're below average across a large number of dimensions that are socially valuable. And that's called the better than average effect. And you see the better than average effect across the spectrum. The Dunning-Kruger hypothesis is that people who score especially low in the ability, they have very little of the ability or lowish levels of the ability, they overestimate their abilities even more than the average person. So it's an interaction. So the degree to which there's a main effect, and then there's an interaction for people scoring at the lowest end. And the way that the data were analyzed to help substantiate this was statistically compromised. And I wrote a paper showing that it's a combination of regression toward the mean and the better than average effect. And when you analyze it properly, you actually don't see the Dunning-Kruger hypothesis anymore, which means that, yeah, there are people who are low in the ability, they overestimate, but they also underestimate. There are people who score low, they think they're awful. And then you see some people who are pretty high. They also rate themselves as quite high. And the Dunning-Kruger hypothesis actually predicted that the people who score really high would actually underestimate their ability more than you see across the spectrum. But I don't think I've ever seen that in a statistically robust way. So people on average overestimate their ability, and the Dunning-Kruger hypothesis was that lower people would overestimate even more. But when you analyze it with statistical techniques that are not ambiguous or less ambiguous, you only see it at the very low end of the tail. It's such a small percentage of people that might be showing it. And even that's kind of dubious from a measurement perspective because the degree of quality and measurement of any ability at the very low end, the reliability is so low that I think it's problematic. So look, I published a couple of papers have been published since, but it's not going away. I'll tell you that. The Dunning-Kruger hypothesis
It's
is
fascinating
here.
because people love talking about it. It's constantly talked
Yes.
about in the sense of misinformation and that type of context. So like, it's just interesting that it's a little bit maybe overdone. But again, a lot of findings kind of end up like that, don't they? Overemphasized a bit.
Yes, very much so. Yes. It's psychologically, people want to say you're stupid and you don't even know it. That's basically
Yeah,
what they want to say on Twitter.
exactly. Exactly. It was an absolute pleasure. Thank you. That was an absolutely fascinating conversation. I learned a lot from it and your papers as well. So I really appreciate you joining me. Thank you.
My pleasure.